Yo, so I wanted to talk a little bit today about the M113k versus the later, 157 and 278s. When I started looking at the numbers and everything, I would always think that like a 113k would kind of end where like a 278 could like maybe get like a couple hundred more horsepower, and a 157 could get like maybe 400 more horsepower, maybe even like 600 if you really push them. Probably not 600. I mean, you'd have to be at like 1400 horsepower. But um but the M113Ks, the compressor engines are faster, and they're quicker. I should say they're quicker. They could do the standing mile, standing quarter mile. I don't know about the standing mile, but they do the standing quarters faster, eighths faster. And I think it has to do with the way the engine builds pressure. So a supercharger is always driven. So right away, you're going to be building boost. It's a mechanical connection. Um, the turbochargers actually need to spool a little bit, and that's sort of like one of the differences between a turbocharged car and a supercharged car. And you'll also see a difference in the horsepower numbers. So, like what I said, you can really get 1400 horsepower out of a or 157, and I guess theoretically you could get about 1,000 out of a 278. But you might run into some compression issues, I guess. The most I've ever seen was like 800, 850, and like a 10.49. Whereas, Eurocharge Texas and all these other guys, Jake and Jerry and, VRP, they're doing sub 10 seconds on these, these E55s and whatever. Um, and there's a difference there too. Like the turbocharger itself is sort of like a small engine, if you will, um, which converts heat into, I guess more power by driving more air and forcing it into the engine. So they're more efficient. Like turbochargers are more efficient, and in theory, you can get more power out of them because there's not like a vampiristic drain. So it actually takes a little bit of power to run a supercharger. They weren't really designed for efficiency. They were designed, I guess, to be awesome. I guess I don't know why they were designed. And in fact, the early superchargers are very different from what we consider a supercharger now. There's an interesting like James Bond film about Ian Fleming, and it's like Spy Maker or something like that. And it's about Ian Fleming's life, and Ian Fleming's life is sort of loosely based on James Bond. And they talk about their like version of Q in real life talks about supercharging one of his cars, which is I think a DB something, but I'm not really sure. Um, but that doesn't mean in terms of drivability and quickness, because there's that mechanical connection that builds boost like that. Even if there's a slight vampiristic uh, you know it takes a little bit of the engine power to actually drive the compressor, right? To actually drive the supercharger. Um, and even though it takes some of that power, it's right away. So once you step on the gas, you're feeling that boost. On a turbocharger, you have to pretty much give it some gas hard and then let it boost a little bit. You need RPM, you need heat. And some people say, I mean, I've seen a couple of YouTubers say, it's really based on throttle input, and maybe they know something about ECU coding. I don't, but that's not how I feel. I feel like turbos are based on RPM, and in fact, you can, like test this out by getting on the highway, keeping it in like I don't know between like 3 and 4,000 RPM, and then always keeping it in that range. Uh, you know, it'll be much faster. And in fact, some cars, some turbo cars, you really have to drive that way because there's so much turbo lag that if you don't keep it between 3 and 4,000 RPM, you just don't have a lot of power. So I don't want to refute anybody, but this is how I think of it, right? is that you need the RPMs to be there to have like a steady flow of exhaust into the turbocharger. Um, so the flip side of this, though, is that the 278 and 157, probably 157, let's take the 278 out of here, but let's just focus on the 157. Let's compare AMG to AMG. That engine, the 5.5 liter twin turbocharged engine, that engine, and I think, maybe the later twin turbos, but let's focus on the 157. They will do like 100 to 200 faster, like 100 kilometers per hour to 200 kilometers per hour. They'll do that faster. Like you can, when you're actually rolling, you'll actually be able to take a lot of cars in, a twin turbo, whatever, whether it's a BMW, twin turbo twin scroll or whatever, or new Mercedes twin turbo twin scroll, or the 157, which has a little bit more displacement but a little bit smaller, less effective turbos. Like you'll probably be able to take a Taycan if it's rolling, you know what I mean? But the Taycan from stop is going to destroy you, even like Hellcats, whatever, because of the way they build power. And like I'm pretty sure a Taycan will take out like a Hellcat, standing eighth. Quarter mile, I would imagine it'd still win. 0 to 60, there's no way. There's just no way an internal combustion engine car is going to really have the ability to, deal with an instant torque type of application that, the Taycan S is putting out, the Turbo S or whatever they call it. And you can actually see it sort of too. They in the 0 to 60 numbers, they do ridiculous numbers, right? But once they're actually rolling, the horsepower drops a lot too. And I don't know why they do that. I guess it's to protect the running gear or something. But like, let's put it this way: a 278 that's like a stage 2, like a CLS 550 stage 2, will probably keep up with or beat a Taycan Turbo S. And I don't want to like say anything right here, although a lot of people are putting out videos of these races or whatever. But let's just say like I know this, but that same Taycan would completely destroy a twin turbo V8 off the line because the power is immediate, it's right away. And then somewhere in the middle you have like naturally aspirated and supercharged engines, and then you have turbocharged engines. We really need to have the RPM and the exhaust flow and the heat to build those power. So I guess it kind of depends what you want to do. If you're into like top speed runs, I would definitely build like a turbocharged car. Like that SSC, something with big turbos, and maybe even like quad turbos or something crazy. If you're into like 0 to 60 launches, like you're not really going to beat a Taycan S. Like, I mean, I don't know what Elon Musk is going to come up with next, and I'm sure he's going to, have something up his sleeve. And there's Lucid, there's a couple other, players out in that space. But the reason why is because it's all electric, right? It's all electric. So torque is 100% torque at 0, like RPM. Like at the first revolution, you get 100% torque. So instantaneous torque. It also, they're very smart, computer-wise. So whereas the computers in like a 278, 157, the like later 4.0, they're actually going to kind of hold back the car a little bit. The computers in like a Tesla or like a Taycan are going to be so smart. And think about it like genius level, like Albert Einstein launch control. You know what I mean? Like they're just going to launch like crazy. But once you're actually rolling and moving, a twin turbo, V8 will likely beat if it's tuned and it's a nice V8 with nice turbos, it'll likely beat a Taycan or similar. So it kind of depends what you want to do. I really do like the 113k engine because basically it's like a Mercedes engine, and Mercedes builds some pretty nice engines that are like pretty reliable. And I don't want to say too much because my car's a Mercedes, not a Mercedes AMG, but Mercedes engines like that one is going to be pretty stout, pretty strong. Um, and then they threw a compressor on it, so it's like an awesome engine with a supercharger. I mean, I love them, and they're solid. You know what I mean? It's a solid engine. The 6.3 liter is a naturally aspirated, so you can really kind of like turn a little bit with throttle input, fine throttle input. But the supercharged cars also are pretty good in terms of throttle input because it is the boost is tied into the engine. That being said, we did have a Jaguar. Like my dad had a lot of Jaguars, and he would let me drive them for like a couple months, 6-8 months at a time, whatever. When I was a kid, and I had like this Range Rover, and it was kind of in the shop a lot. So anyway, I was driving this supercharged Jaguar, and we did a pulley upgrade, and we changed a lot of stuff on it, and that car kind of built boost higher. So you did lose a little bit of drivability, low RPM with it. Um, so I know you can have issues like that. But in general, supercharged engines are going to be pretty lag free. They're going to be pretty responsive. Not as responsive as a naturally aspirated, probably. I mean, there's always exceptions to the rule. And definitely probably not as responsive as an electric car. Um, just because you got the computers running really fast, you've got instantaneous torque, and then on the other hand, you have like turbocharged cars, and the bigger the turbos, the more you have to take them into account and how they actually build power, which is from the RPM, from the gas build up. You start getting the spinning, it starts moving it through and forcing more air into the engine. Um, And it kind of demonstrates the difference. And I'll just say one more time, like if you're going to try to build a Mercedes today for like a standing quarter mile or something, the M113k is going to be a really good bet, like a E55. And you can just look up the times on Draggy. Um, so if you're trying to build like a car for top speed or rolling races, you're going to want a turbocharged car because of how they build the power. They're actually getting more power. They're more efficient. Like so, they're going to they're really like you can kind of think of turbochargers like small engines, or motors, I guess. I mean, it's not really what they're like turbines or something, but they're like extra engines. You can kind of think of them like that. You're going to get more power out of it. You just have to make sure the engine itself can keep up. And so that's where methanol injection comes in. So if you were really going to go do like a top speed car with like passes, 100 to 200 kilometers per hour is a very kind of a popular race, popular time. The methanol injection, the Nazis actually figured this out with their turboprop planes. Or no, I guess they're not turbo. They're turbocharged engines that drove propellers. They threw in methanol, and they were able to get like just ridiculous more horsepower out of these engines. So like, let's say they were like 2,000 horsepower engines. I think they were like 1,400 horsepower. Let's just say. They were getting almost 2,800 horsepower when they were getting, the methanol because it was able to allow the engine to be cool and not, get too hot and be able to just force in a ton of air at the same time. So I'll just pull up a leaderboard really quick. If you pull up like a 0 to 60 all-time history here, uh, you'll see there's one guy in Dubai with an AMG GT, so exceptions to every rule. But the next guy, Eurocharged, is 2004 E55, and that's at 9.65 seconds, right? So let's go to like 100 to 150 miles per hour. I don't see why they don't have the 100 to 200 kilometers, but whatever. All right, so here's history, and here you see GAD is on top with a C63 2011, and then next to him is an AMG GTS, also turbocharged, 2014 E63, also turbocharged, and the 2014 E63 would have bigger or like more displacement, like 1.5 liters more displacement, but it's going to have like smaller turbos likely than the GT. And then you can see DTK over here, Dimitri at 5.51 seconds. He's got a kit, basically it's about $10,000. It brings a M157 to 1,000 horsepower, and that's like a daily driver. So yeah, you can either reach out to me, you can reach it, or I can connect you with him and grab that kit. VRP and other guys have similar. It would probably be close to like a W3 kit from Weistech, I would guess. And there's, I think, more power to even be made from this. There is a point of diminishing returns, but in theory, if you could put the power down, and that's a big if, there's ball bearing turbochargers and things that a lot of people don't really use yet. They're sort of kind of exotic, they're kind of newer. And, I don't want to say that like too forcefully because maybe, people, have used them before, but they're sort of, becoming a little more popular. So in terms of turbo upgrades, you have like a hybrid turbo upgrade where you use the existing turbo and they usually do better like compressor wheels, they're balanced, and it's called like a billet turbo upgrade. So the wheels themselves are manufactured different into a higher degree, right? And then sometimes they like shave off some of the housing and whatever, so they optimize the existing housing. So like if you had a 278, a really popular upgrade would be to do like an M157 hybrid turbo upgrade. And that's where you would go about doing that. Maybe get 157 turbo takeoffs and then send them to VRP or someone, and they would upgrade them for you. I don't think Dimitri charges for cores, which is pretty insane if you actually think about it. But like pure turbo would be another group. Weistech also. Then you have aftermarket, like just different types of turbos, so different housing, different manifolds sometimes, and then you'll have like ball bearing turbochargers, which I'm not like a turbocharger expert. Like there's, if you really want to get into turbos, they're really cool. They're the basis of a lot of different types of other technologies. Like you can kind of think of like airplane, like jets, and other compressors. They're all kind of related. And it's something I'm interested in. I'm not going to speak to it too much because I don't know enough to speak about it too much. It'd be like me commenting on like the difference between like a Daytona movement versus like a Breitling movement. Like I know that they're different. Like I know the Daytona movement is like more reliable than the Breitling movement. But maybe some of the stuff about vertical clutches and stuff. So I can comment about that, and that's kind of what I'm trying to give you here. But Tasso, he has an awesome channel, but again, he's sort of more general. I don't know if I've ever seen him go really deep into turbos, but turbos are deep, man. They go deep. I mean, jet engines really are similar to turbos. Like power plants also can use turbos. Um, like compressors. I mean, I think you could even use turbos in a nuclear power plant. I mean, they're not called turbos at that point. They're called, something else, but they're kind of similar. They use like the heat to move a, something else. And in a car, like an internal combustion engine, they drive more air into the engine. I do think we might see turbochargers in the future that are slightly different, and we've seen electric turbochargers. That's kind of a newer thing, and even some, so that would spool a little bit faster, and then it would start to use the exhaust. There might be some like weird eBay ones, but in general, that's sort of what you would go with that. Um, and one of the reasons why a Mercedes might put a supercharger and a turbocharger on a car, like the 53 engines have both, is to eliminate some of the turbo lag. Um, so that, you don't have to change your driving to accommodate the turbos as much, and so that they can have better off the line performance. And they put in like a 48-volt starter, so the start stop is more seamless. Because the starter is like part of the generator. So I mean, I think we might see some really interesting things if electric vehicles don't just take over. And part of me hopes they don't, because I think there are some really cool applications of like diesels and maybe like some sort of like a turbo that drives like I don't know, power to a battery pack. So you have like an internal combustion engine. You take some of that exhaust power and drive it to like, maybe some sort of an electrical system, or other sort of a hybrid system. And then maybe, you have like actual electric motors too. So you could have like, I don't know, kind of similar to like what an Acura NSX setup would be like, the newer ones where you have like little power motors at the front wheels. You could probably drive those off turbochargers and like a battery pack running from an internal combustion engine. So I'm not even sure they'd be considered turbos at that point. But, we're kind of off. The next thing we're going to be talking about is like, I don't know, like gravity warp drives or whatever. So anyway, let's not talk about anything more. I think we've done enough damage. And yeah, anyway, thanks for watching.